Okay. So now, the next thing that I'd like to do is to give you a second proof, because it really is important, I think, to understand this particular fact more thoroughly, and also to get a lot of practice with sines and cosines. So I'm going to give you a geometric proof of the formula for sine here, for the derivative of sine. So here we go. This is a geometric proof of this fact. This is for all theta. All right, so far we only did it for theta equals 0. And now we're going to do it for all theta. So this is a different proof, but it uses exactly the same principles. All right? So I want to do this by drawing another picture. And the picture is going to describe y, which is sine theta, which is the, if you like, the vertical position of some circular motion. So I'm imagining that something is going around in a circle. All right, some particle is going around in a circle. And so here's the circle, here's the origin, this is the unit distance, and right now it happens to be at this location P. All right, maybe we'll put P a little over here. And here's the angle theta. All right, and now we're going to move it. We're going to vary theta, and we're interested in the rate of change of y. So y is the height of P, but we're going to move it to another location. We'll move it along the circle to Q. All right, so here it is. Here's the thing. So how far did we move it? Well, we moved it by an angle delta theta. All right, so we started theta. Theta is going to be fixed in this argument, and we're going to move a little bit delta theta. And now we're just going to try to figure out how far the thing moved. Well, in order to do that, we've got to keep track of the height, the vertical displacement here. So we're going to draw this right angle here, and this is the position R. And then this distance here is the change in y. All right, so the picture is we have something moving around a unit circle, a point moving around a unit circle. It starts at P, it moves to Q. It moves from angle theta to angle theta plus delta theta. And the issue is, how much does y move? And the formula for y is sine theta, so that's telling us the rate of change of sine theta. All right, well, so let's just try to think a little bit about what this is. So first of all, I've already said this, I'm going to repeat it here. Delta y is PR. It's going from P and going straight up to R. That's how far y moves. That's the change in y. That's what I said up in the right-hand corner there. Oops, I said PR, but I wrote PQ, huh? All right, that's not a good idea.